Namaste students, welcome back to Rama Teaches You. Today we are going to do motion in a plane, the English video, part number 5. Okay, and we are going to do the numericals in this class. Hopefully we'll be able to finish this chapter in this video and then we'll do some more numericals. A body of mass m1 equal to 20 kg is placed on a smooth horizontal table. This body is connected to a string which passes over a frictionless pulley. The string also carries another body of mass m2 equal to 10 kgs at the other end. Find out the acceleration which will be produced when the nail fixed on the table is removed. Okay, there was a nail there that was holding this all together. When the nail is removed, okay, also find the tension in the string during the motion of the body. What is the result when the body stops? What is the result when the bodies stop? Take G is equal to 10 newtons per kg. Okay. So when the nail is fixed on the table, the system of two bodies move with an acceleration of a. Why? Where is the nail? A body of mass m1 equal to 20 kgs. The body is connected. Okay. Uh, where is the nail? When the nail fixed on the table is removed. Oh, okay, fine. When there is a small nail here. Okay, there is a small nail here which is stopping this mass m1 from sliding towards the right. Okay, when the nail fixed on the table is removed, the system of two bodies move with an acceleration a. Right, this m2 is going downwards, this m1 is going towards the right. The acceleration can be found using Newton's second law. From the free body diagram of each body as shown in figure, we know that in m2 you have m2g acting downwards and there is a tension acting upwards, right? There's a tension acting upwards. Now, here what is happening? This tension here, there's a tension like this going. Okay, there's a tension like this going, and this is basically making the body M1 move. M1 has what all things? M1 has M1G in the downward direction. You have the normal reaction in the upward direction. Now, Drupal, is the mass M1 moving in the vertical direction? No, it is not moving in the vertical. It's not moving in the vertical direction. Therefore, R should be equal to M1G. Okay. So we know that T is equal to M1A. There is a movement here when the nail is fixed. For mass M1, you have what? Tension is equal to M1A. That is, since these two vertical forces are cancelling each other out, what happens? The only force that is acting on it is tension, and this tension is causing this mass to move in the forward direction. So we can write tension T is equal to MA, M1 into A for the first body. And for the second body, we know that the body is moving downwards. If the body is moving downwards, then what will be the equation? What is the force that is acting downwards? What? I can't hear you. Can you speak up louder? Yeah, mg. And what is the upward force? The tension. No, it's not the normal force, Rupert. It is tension. Okay. Now, so if the overall body is moving downwards, then what happens? M2G minus T should be equal to M2 into A, right? Because the overall direction is in the downward direction. Therefore, downward minus upward is equal to downward, right? Downward force downward force minus upward force should be equal to downward motion, right? So these are the two equations that we got. Adding these two equations, what do we get? We get, so T is equal to MA, M2G minus T is equal to MA. If you add them both up, so you will get M2G, M2, this is um, M1 is M2. So M2G should be equal to M1A plus M2 into A, right? This is the formula that you get, M2G, because these two gets cancelled each other out. Okay. Now, what do we get? Acceleration is equal to what? We know that M2G is equal to M1 plus M2 into A. Therefore, A becomes M2G upon M1 plus M2, right? Clear? So we just put the values and we'll get 3.33 meters per second square, right? And what is the tension on the string? The tension on the string is T is equal to M1 into A. Therefore, we put the values of M1, that is 10 kg, multiplied by 3.33 meters per second square. We will get 33.33 newtons. Clear? Next, when the bodies stop accelerating, A will be 0. Suppose the tension T as the net force on each body is 0. So for the body M2, T is equal to M2G. See, why when it is stopping, look at this diagram. When the body is stopping moving, it is stopping its motion, then M2G minus T is equal to M2 multiplied by A, right? So M2G minus T is equal to M2 multiplied by 0. So you will get what? M2G is equal to T. M2G is equal to T. So what is the value of M2? M2 is how much? The M2 is 10 kgs. Okay. So 10 kgs multiplied by 10 is, you will get 100 newtons. Exactly. So tension will become equal to M2G. Any doubts in this question? Perfectly straightforward, right? So what happened here? When the body stopped moving, when the body stopped its motion, what happened? When the body stopped its motion, the acceleration became 0. When the acceleration became 0, basically M2G, that is downward force minus upward force, became 0. Therefore, downward force became equal to upward force, and that's how we got this answer. Clear? Okay. Now, question number 17. Two bodies of mass, one second. Two bodies of mass 10 kgs and 20 kgs respectively, kept on a smooth horizontal surface, are tied to the ends of a light string. A horizontal force of 600 newtons is applied to A and B along the direction of the string. Okay, so what is happening here? Two bodies of mass 10 kgs and 20 kgs. I'm just going to draw this here. So, two bodies of mass 10 kg and 20 kg respectively, kept on a smooth horizontal surface, are tied to the ends of a light string. Okay, are tied to the end of a light string. Horizontal force of 600 newtons is applied on A. So you are applying a force of 600 newtons here. Newtons here is applied on A. Number two is B along the direction of the string. What is the tension in the string? Okay, so there is no friction here because it's a smooth horizontal surface. So when a force is applied on A, what happens? You apply a force here. So mass of what is happening here, this M1, this M1 is basically causing two forces. Okay, mass M1 has two forces. One force in this direction, which is tension, one force in this direction, which is F, right? So mass of body A is 10 kgs, mass of body B is 20 kgs, force applied is 600 newtons. For a body A, T minus F minus T, right? Because it is moving in this direction. So whichever direction it moves, this is 10 kgs. If it is moving in this direction, can I say that F minus T should be equal to M1 into A, right? You are applying a force. Therefore, F minus T should be equal to M1 into A. Now, for the body B2, B2, what is going to happen? Here the only force that is being acted on 20 kgs is what? This force. This force is being applied here. So only tension is being applied on the second body. There is tension as well as force being applied on the first body, but there is only tension being applied on the second body. So the force there becomes, so basically the tension becomes equal to m2 into a. So tension is equal to m2a. Now Drupad, how do we understand this? This body of mass 10 kg was being applied a force of 600 newtons in this direction. Tension was in this direction. So what ended up happening? F minus, that is applied force minus resistive force, should be equal to m1 into a. Here, because on the 20 kg load, there is only one force being acted on. What do we get? We get T is equal to m2 multiplied by a. So what are we going to do? We are going to put the value of T, that is m2 into a, in this above equation. Okay, if we put this in the above equation, what do we get? F minus m2 into a is equal to m1 into a. Therefore, F is equal to m1 plus m2 multiplied by a. Therefore, a is equal to what? F upon m1 plus m2. F is 600 upon m1 is how much? 10 and 20, right? It's 10 and 20? Yeah, 10 and 20. So we get 30. 10 and 20, we get 30. So this gets cancelled. So we'll get 20. Acceleration becomes 20 meters per second squared. Clear? Acceleration becomes equal to 20 meters per second square. Am I right? Any doubts here? So what is the tension here? So what have they asked us? A horizontal force is acting on the string. What is the tension in the string? So we know that from this formula, T is equal to M2 into A. So tension is equal to 20 multiplied by 20. So tension becomes 400 newtons. Understood? So the tension has become 400 newtons here. Clear? Any doubts? So what happened here? Basically, you had a force being applied on the 10 kg load. So the 10 kg was experiencing two different forces in two different directions. So we drew the free body diagram as F minus T is equal to M1 into A. Correct? And since there was only one force being acted on by the on the 20 kg load, you had tension only. So tension is equal to m2 into a. So tension became 20 into 20. Sorry, the force became F minus m2a is equal to m1 into a. F is equal to m1 plus m2 into a. Acceleration became 20 meters per second square, and you use this value here to put the answer. Any doubts? Okay, let's move on to the next one. Okay, so if the same force is being applied on the 220 kg load, what happens? So you have the 20 kgs here, you have the 10 kgs here. Okay, spring 600 newtons. So for the 20 kg load, now there is two forces acting. There is 600 newtons acting here, and there is tension being acted upon here. On the 10 kg load, you have only tension acting here. Okay, so again you do the same process here. So T F minus T is equal to M2 into A, and similarly T is equal to M1 into A. You put this in this formula, what do you get? You will get F minus M1 into A is equal to M2 into A. Therefore, F is equal to M1 plus M2 into A. Therefore, A is equal to again F upon M1 plus M2. So, you will get the same acceleration here also. 600 upon 30 is equal to 20 meters per second squared. Okay, you are getting the same acceleration here also. Okay, but the tension will be different because the tension here is how much? M1 multiplied by A is equal to, what is the value of M1? 10 multiplied by 20 is equal to 30 meters per, sorry, 30 newtons. So in both the cases, the tension is the only thing that is changing. Understood? The tension is the only thing that is changing. Clear? And you can understand this also. So how does this happen? Just hold on one second. How does this happen? If you are a heavy body and you're trying to pull a light body, okay, if you're trying to pull a light body with a string, then what happens? The string does not have that much tension on it. But if you are a light body and you're trying to pull a heavy body, then what happens? Even if the force is the same, the tension on the string actually increases. Okay, the tension in the string increases. That is one of the major reasons why if we try to basically move a car or a very heavy object with a thin string, what ends up happening? It breaks the string, right? But if the car is actually trying to move us, if the car is trying to move us with the same string, it may not break because the tension on the string is not that high. Understood? Clear? So with this is basically how you need to understand. This is the explanation that is required in this question. Clear? So if you apply it in real world, if you apply it in real world, if you have two bobs, okay, if you have basically two bobs like this, let's say, mm, okay, this is you and this is the mass. Okay, you're trying to pull the mass towards you. Because it is heavier, the tension will be higher. Okay, but if the mass tries to pull you, the tension will be lower. Clear? Wait, did I make a mistake? Oh, I made a small mistake here. No, wait, did I make a mistake? Oh, yeah, sorry. I added them up. 200 newtons. 10 into 20 is 200 newtons. Brain not braining. Okay, fine. Consider the body of mass m is suspended by two strings, making an angle of alpha and beta with the horizontal as shown in the figure. If the body is in equilibrium, then find the tension on the string. Okay, I think it should be easy. Let's see. So you have beta, you have alpha. This is T2, this is T1, and this is mg. The downward force is mg. Okay. Now, Drupal, what is this angle going to be? 90 minus beta. So this angle is 90 minus beta, and this angle is 90 minus alpha, right? So what can I do? I can basically uh, resolve this force T1 and T2 in the horizontal and vertical direction. Okay, so let's actually draw another free body diagram like this. Okay, so you have, this is T2, this is 90 minus beta, and this is T1, this is 90 minus alpha. Okay, so this T2 can be T1 can be resolved as T1 cos 90 minus alpha like this, and this can be resolved as T2 cos 90 minus alpha like this. Sorry, 90 minus beta, 90 minus beta. This becomes what? T1 sine 90 minus alpha. This becomes T2 sine 90 minus alpha. What is sine 90 minus alpha? And cos 90 minus alpha is sine alpha, right? So this becomes what? These two become T1 cos alpha. This becomes T2 cos alpha. Sorry, T2 cos beta. This becomes T1 sine alpha, T2 sine beta. So if I remove everything else, if I remove all the forces, I will get that there are only three vertical forces here, mg. So if this object is in equilibrium, can I write T1 sine alpha plus T2 sine beta is equal to mg? And since the object only has two horizontal forces, both of them acting in the opposite direction, can I write T1 cos alpha is equal to T2 cos beta? Any doubt still here? Since both the horizontal forces are balancing each other out and vertical forces are balancing each other out, I have written these two equations. Any doubts here? Okay, fine. What have they asked us to find? If the body is in equilibrium, then find out the tension in the string. Okay, tension in the strings. So, what are we going to do? What can we do? From the second equation, can I put the value of T1? Can I substitute the value of T1 based on T2 or T2 based on T1? What have they done? They basically substituted the value of T2. So T2 is equal to what? T1 cos alpha upon cos beta. You'll put this in this thing. Okay. So what do you get? T1 sine alpha plus T1 cos alpha upon cos beta dot sine beta is equal to mg. Have they given us the values of alpha and beta? No degrees, right? Nothing has been given. Okay. So what do you get? T1, I'm taking the value of T1 out. Sine alpha plus cos alpha. Sine beta upon cos beta is tan beta is equal to mg. Therefore, T1 is equal to mg upon sine alpha plus cos alpha tan beta. This is the value of tension in T1. So T2 becomes equal to what? T2 is T1 cos alpha upon cos beta. So T2 is equal to mg upon sine alpha cos alpha, sorry, sine alpha plus cos alpha tan beta multiplied by cos alpha upon cos beta. Okay, if you open this up, you will get the answer for T2 also. I think these are the two answers. One second. Yeah. Uh, okay. Okay. They did something else. What did they do? They basically did this. This is also correct answer only. That what I have written is correct only, but they have written it something else. So T1 cos alpha sine alpha cos beta plus T1 cos alpha sine beta upon cos beta is equal to mg. Therefore, what they did was T1 sine A cos B plus cos A sine B is equal to how much? Sine of A plus B. T1 sine alpha plus beta upon cos beta is equal to mg. Therefore, T1 is equal to mg cos beta upon sine alpha plus beta. This is what they got. Okay, clear? Okay. Now, what should be the value of T2? Okay, so T2 is equal to T1 cos alpha upon cos beta is equal to T1 not T1 your mg cos beta upon sine alpha plus beta multiplied by cos alpha upon cos beta. This gets cancelled. So we'll be left with mg cos alpha upon sine alpha plus beta. So this is T2. Clear? Any doubts in this question? So what did we have to do? We had to resolve the tensions T1 and T2 in the horizontal and vertical direction. Again, I'm telling you, vectors is a very, very important chapter for the rest of physics. Okay, so we resolved it into two cos and sine components. Okay, and then we basically equated them because the whole system was in equilibrium. Therefore, we equated it. Okay, clear? Okay, let's move on. Just one second. Yeah. Okay. Determine the tension T1 and T2 in the strings as shown in figure. Okay. Next. So you have a ceiling like this and walls like this. Okay. So this is T2. This is T1 and this is 4 kg weight. 4 kg weight is how many newtons? What is 4 kg weight equal to, Drupad? 40 newtons exactly. Okay. So they have written 4 kgWt is equal to 40 newtons. Okay. So the only force that we have to resolve is this T1 force. I'm going to resolve this T1 force like this. One second. But before that, this is 60 degrees, right? So this also becomes 60 degrees. Okay. Because alternate interior angles. Now, these are the two forces that I'm going to resolve it with. So this becomes T1 cos 60 degrees and this becomes T1 sine 60 degrees. Any doubts in the resolving part? No, right? Okay, fine. So I because this whole system is in again equilibrium, I can say that the horizontal components of force, the horizontal forces should be equal and the vertical forces should be equal in the opposite direction. Okay, the and should have equal and be at okay. The horizontal and the vertical components should be equal in magnitude and be at opposite direction. So what do we get? T1 sine 60 degrees should be equal to mg and T2 should be equal to T1 cos 60 degrees. Okay, so we can find T1 by equating these two, and from T1 we will get T2 also. Okay, so T1, what is sine 60 degrees? Root 3 by 2 should be equal to 40 newtons. So T1 is equal to 40 into 2 upon root 3. Okay. So now we know that T2 is equal to T1 cos 60 degrees. What is cos 60 degrees? Is equal to T1 by 2. So T2 is equal to 40 multiplied by 2 upon root 3 multiplied by 2. This gets cancelled. You will get 40 upon root 3. Now if you want to rationalize the denominator, what do you get? You will get 80 root 3 upon 3. Here you will get 40 root 3 upon 3. I have rationalized the denominator. That's it. Clear? Any doubts? No problem, right? Tensions are easy questions. I want to start IIT questions now after this. So, next. See in figure a mass of 6 kg is suspended by a rope of length 2 meters from the ceiling. A force of 50 newtons in the horizontal direction is applied at the midpoint P of the rope as shown in figure. What is the angle the rope makes with the vertical in equilibrium? Okay, let's do this. So, let us look at the diagram. There is tension here. Okay, there is a downward force of 60 newtons. Okay, there is a force like this of 50 newtons. This is T2, this is W, and we have to find the value of T1. This is T1, and this whole system is in equilibrium, and we have to take the value of G as 6. Okay, so we have 60 newtons in the downward direction, and if oh, they haven't given us the value of theta. Wait, see in figure a mass of 6 kg is suspended by a rope of length 2 meters. You have a 2 meter long. Oh, this is 2 meters. No, wait. A force, see in figure, this is the weight. See in figure a mass of 6 kg is suspended by a rope of length 2 meters. Okay, so a force of 50 newtons in the horizontal direction is applied at the midpoint of P of the rope. What is the angle the rope makes in the vertical with the equilibrium? Oh, we have to figure out the value of theta. Okay. We have to figure out this angle theta. So if P is the midpoint and this is the mass. Okay. If this is the mass, then this is 1 meter and this is also 1 meter. Okay. Clear? This is also 1 meter and this is also 1 meter. Okay, so what do we do? What do we do? What do we do? Okay, we need to make two equations now. Let's make two equations. So I'm going to first resolve this T1. Okay, so let's see. This becomes T1 cos theta in the upward direction and this becomes T2, sorry, T1 sine theta, and this whole system is in equilibrium. Okay, so what do I get? T1 cos theta is equal to mg, that is T1 cos theta is equal to 60 newtons. Similarly, T1 sine theta is equal to 50 newtons. Hmm. Can I do something? Um, can I take the value of T1 is equal to 50 upon sine theta from this equation, and I'll put this here. So T1 cos theta is equal to 60 newtons. Therefore, T1 50 upon sine theta multiplied by cos theta is equal to how much? 60 newtons? No. Yeah, 60 newtons. So 50 cot theta is equal to 60. This and this gets cancelled. Cot theta is equal to 6 upon 5. So I can write this as tan theta is equal to 5 upon 6. Okay. So theta is equal to tan inverse 5 upon 6. This is the angle that we need. Clear? So what is theta? Tan inverse 5 divided by 6. 39.80. So theta is equal to 39.80. Clear? So this becomes 39.80. Let me just see if it's correct or not. Yeah, 39.80 they have considered to be 40 newtons. Okay, so theta is coming out to be 40 newtons. Any doubts in this question? If you want to find the value of theta, all you have to do is basically, so T1 is equal to how much? T1 is equal to 60 upon cos theta. T1 is equal to 60 upon cos 40. Cos 40. Cos 40. 0.76. So T1 is equal to 60 divided by 0.76. 60 divided by 0.76 equals T1 is equal to 78.94. Okay, so you have figured out the value of T1, you figure out the value of theta, understood? All by resolving the tension in two different directions. Clear? Any doubts here? We were trying to find the angle theta here. This angle theta, no, this angle theta and the tension. Okay, theta and the tension are the ones that we were supposed to find. Okay, so this 1 meter, yeah, what? I don't, no, tension is not there. Oh, anyways, but you understood, no, how to find the tension also. Yeah, it's fine. Okay, let's look at some questions. Numerical problems. Let's start with numerical problems. So, Drupad, I want you to take a copy with in front of you, copy and a pen in front of you. I'll wait. Number 7. Question number 7. A heavy point mass tied to the ends of a string is whirled in a horizontal circle of radius 20 centimeters with a constant angular speed. What is the angular speed if the centripetal acceleration is 980 centimeters per second square? Okay, so we know that centripetal acceleration A is given as what? V square. This one, question number 7. Okay, so we know that acceleration is equal to what? V square upon R, right? Okay, and we also know what is the angular speed. Angular speed is, you know what? Angular speed is angular velocity. Okay, they're asking us to find that. So acceleration is equal to V square upon R is equal to omega squared R. Okay, so omega squared is equal to acceleration upon R. Omega is equal to root under A upon R. Understood? Root under A upon R. So what is the angular acceleration? Is equal to Drupal. Is there a problem with us not converting the centimeter into meter? Do we have to? Why? Because the centimeter in the numerator and the denominator will cancel each other out and we don't have to worry about it. So root under 980 centimeter, 980 divided by 20. So this becomes root 49 is equal to 7 radians per second. Understood? Omega becomes equal to 7 radians per second. Any doubts here? Okay, let's move on to the next one. You also solve it. I may make careless mistakes. So if I make careless mistakes, you should be able to rectify me. Next, what is the acceleration of a train traveling at 50 meters per second as it goes through a as it goes around a curve of 250-meter radius? Again, a very easy problem. So we know that angular acceleration is equal to what? V squared upon R. Okay, so angular acceleration is equal to 50 the whole squared upon radius is 250. So what do we get? 2500 upon 250 is equal to 10 meters per second square. Is it correct? Okay, next one. A body placed on a rough inclined plane just begins to slide when the slope of the plane is equal to 1 in 4R. Oh, 1 by 4. The slope is what? What is the representation of slope, Drupad? How is slope represented as? How is slope represented as? What is slope? Tan theta. Tan theta. Slope is equal to tan theta is 1 in 4. 1 in 4 becomes 1 by 4. Calculate the coefficient of friction. The coefficient of friction is tan theta only, right? Yeah. So is that the answer? 1 by 4. Just hold on. Okay, just one second. Let me just. I was wrong. Slope 1 in 4 does not mean this. Okay. If you have a slope like this, 1 in 4 means 1 here and 4 here. This is what 1 in 4 means. Okay. It's not 1 upon 4. It is 1 in 4. So basically, for the how do you say this? For every 1 meter in height, you will have a slope of 4 meters. Okay. For every 1x in height, you will have 4x as your slope. That's what 1 in 4 means. You understood this wording? 1 in 4? Okay. So let's call this theta. What? But the what do you say? The coefficient of friction is tan, right? No, normal. You can always do this thing. No, what do you say? Pythagoras theorem. This will become what? This will become 16 minus 1. 4 square minus 1 square, which is root 15. So we know that the coefficient of static friction should be equal to tan theta. So therefore, so mu of s is equal to 1 upon root 15. Isn't this easier? Okay. I know you can do that also. You can use the sign to find your this thing and all of that. You can do that. That's also fine. No problem. Next. Figure below shows a man standing standing stationary with respect to a horizontal conveyor belt that is accelerating with 1 meter per second. What is the net force on the man if the coefficient of static friction between the man's shoes and the belt is 0.2? Up to what acceleration of the belt can the man continue to be stationary relative to the belt? Oh, nice question. Okay, wait. So, what is the net force on the man? Figure below shows a man standing stationary with respect to a horizontal conveyor belt. Oh, the conveyor belt is moving. He is stationary with respect to the belt, and the belt is moving with 1 meters per second. What is the net force? 1 meters per second square. So, what is the net force on the man? If the coefficient of static friction between the man's shoes and the belt is 0.2, up to what acceleration of the belt can the man continue to be stationary relative to the belt? So, okay, he is moving with an acceleration of 1 meters per second square. This conveyor belt is moving with an acceleration of 1 meters per second square, and there is a frictional force here. There is a frictional force here. If the man is stationary with respect to the belt, hmm, should it be zero then? 1 second, let me see. Hmm, okay. The man is stationary on the belt. The belt is moving forward with acceleration 1 meter per second squared. Okay, so the man is stationary on the belt. The belt is moving forward with an acceleration of 1 meters per second square. So the overall force should be 1 meters per second square, right? The net force is equal to MA. Net force should be equal to your MA value. Therefore, 6,000 newtons, 600 newtons, right? Yeah, 650 newtons. 65 multiplied by 10 is 650 newtons. The mass of the man is 65 kg, da. Oh, sorry. Sorry. 65 newtons. A is 1 meters per second. 650. I thought, never mind. Okay. So, what is the, if the coefficient of static friction between the man's shoes and the belt is 0.2? So, the man is standing here. So his weight is mg. Since he's not moving in any vertical direction, so R is becoming equal to mg. And we know that static friction is equal to what? Mu s R is equal to mu s mg. So what is mu s mg equal to? F of s is equal to mu of s is how much? 0.2. M is how much? Mu s, M is 65 multiplied by 10 is equal to 10, 0.2, that is 66, 600, no, 130 newtons. Am I right? The static friction is how much? 130 newtons. Have I made a calculation mistake? Okay, fine. So, no, 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 no. The person should not slip. What have they said? They have said that what is the net force if the coefficient of static friction between the man's shoes and the belt is 0.2, up to what acceleration of the belt that can the man remain stationary? Okay, he has to remain. So look at this. This is the question. The belt is moving, but he has to remain stationary relative to the belt. F. See, the frictional force should be equal to the forward force. Okay, for him to remain stationary, if there are two forces acting on him, this conveyor belt is moving like this. If there are two forces acting on him, this force should be equal to your frictional force. So, F into M into A should be equal to your Fs. Acceleration should be equal to Fs upon M. So, what will we get? 130. Should this be the answer? Oh, yeah, yeah, okay, fine. Yeah, that's fine, that's fine. So if the belt is moving at 2 meters per second square, at maximum acceleration of 2 meters per second square, the belt will remain stationary. Clear? Any doubts? Okay, next. Uh, a body of mass 2 kg is being dragged with a uniform velocity of 2 meters per second on a rough horizontal plane. The coefficient of friction between the body and the surface is 0.2. Calculate the amount of heat generated per second. Why do we need? Okay, fine. G 9.8 meters and J is equal to 1 joule is equal to 4.2 joules per calorie. Yeah. What? A body of mass 2 kg is being dragged with a uniform velocity of 2 meters per second on a rough horizontal plane. The coefficient of friction will. So you have a mass of 2 kgs is being dragged uniformly with a velocity of v is equal to 2 meters per second. The coefficient of friction between the body and the surface. So mu of k is equal to 0.2. Calculate the amount of heat generated per second. Take g is equal to 9.8 meters per second square and j is equal to 4.2 joules per calorie. What is j? Dhruvat, what is j? But what? How can joules be joules per calorie? Just 1 second. So, if it is moving with a constant velocity, the applied force should be equal to your frictional force. Let's understand what frictional force is. Okay, so the 2 kg mass acting downwards is how much? You can call it 2 G's. I'm just going to keep it 2 G's, and therefore this is also R. Therefore, since there is no vertical motion, R is equal to 2G. Okay, so friction is equal to how much you have? Friction is equal to um, mu of R is equal to mu of k mg is equal to 0.2 multiplied by 2 multiplied by 9.8. 0.4 multiplied by 9.8. So what is this going to be? 9.8 multiplied by 0.4 is how much? 400 minus 400 minus 8 is how much? 39.8, 39.2, right? Wait, sorry. 9.8 multiplied by, my brain is really not working today. 39. Oh, I was right. 39.2. Okay. So this is 39.2 newtons. The coefficient of friction between the body and the surface is to calculate the amount of heat generated. Okay. So first let us calculate how much work is done by the body per second. Okay. How much work is done by the body to calculate the heat, to calculate the heat we must friction. We must calculate how much work is done by friction. And we know that work done is equal to force multiplied by distance. Therefore, work done is equal to the frictional forces 39.2 multiplied by d. How do we calculate d? We know that speed is equal to distance upon time. Therefore, distance is equal to speed into time. Time is how much? 1 second. Per second, they are asking us. So, time is 1 second and speed is 2 meters per second. So, distance traveled per second is how much? 2 meters. So, work done is equal to 39.2 multiplied by 2. So, 40, 80 minus 15 is uh, 78.4. Is this correct? 2 to the 4, 2 another 18, 2, 3, 6. Yeah, 78.4 joules. Okay. Is there any doubt till here? The work done by friction. Any doubts? This is not the answer. This is not the complete answer. Okay. So work done is always equal to J multiplied by H. Okay. This is something that we are going to learn in the thermal coefficient. Okay. Thermal properties of conductors and insulators. So the heat generated will be equal to work done upon J. Clear? And they have given us the value of J. Look at this. They have given us the value of J as J is the basically, I think it is the coefficient of something, something, something. I don't remember it exactly. Some science specific heat capacity or something like that. Okay. So, yeah, basically they're saying that the amount of work that is being done, okay, only a certain portion of it is getting converted as heat. The logic behind, I will explain to you the logic. So, the whole that work that you're doing is not getting converted into heat. Only a specific small amount of work that is being done is getting converted as heat. Do you follow till now? That this basically J represents the amount of work done. So J represents the amount of work done that is actually being converted into heat. Okay, so it is just a fraction. So the heat generated will be equal to what? Heat is equal to your 78.4 divided by 4.2. So 78.4 divided by 4.2 equals 18.66. 18.66 joules of heat will be generated. Okay. So what is J? J is just a fraction which is showing us like this much amount of work from if you have this much amount of work, this much quantity is getting converted into heat. It can be known as efficiency also. Like something like that, but it is not exactly. I think in the next chapter we will be able to understand this further. Understood? So J, the portion of work done which is actually getting as heat. Okay. So work done upon heat should be equal to J, or work done should be equal to J times H. Clear? Doubts? Okay. I'm also seeing this type of question for the first time. Next. A stone of mass 0.25 kg, a stone of mass 0.25 kg tied to the end of a string is whirled around in a circle of radius 1.5 meters. Okay. So 0.25 kg, that is 250 grams. This radius is 1.5 meters. What else have they asked us? With speed of 40 revolutions per minute. So speed is given as 40 revolutions per minute. Per minute. What is the tension in the string? We need to find tension. Tension will be equal to what, Drupal? If you are basically rotating an object like this, what will be the tension equal to? Who is providing you with the tension? Yes, exactly. The centripetal force is providing you with the tension. What is the maximum speed with which the stone can be whirled around if the string can withstand a maximum tension of 200 newtons? So they have given us T max is equal to 200 newtons, and they are asking us to find the maximum speed. V is equal to question mark. Okay, I think we can do this. So speed is equal to 40 revolutions per minute. It doesn't help us at all. Okay, so 40 revolutions per minute does not help us. What is one revolution equal to, Drupat? One revolution. We'll find the omega first. Omega is equal to how much? 40 revolutions per minute means what? 40 multiplied by 2 pi. It is getting rotated 40 times, right? So per minute becomes what? Upon 60. 1 minute is how much? How many seconds? 60. So you will get 2 for 2 20 into 2 the 40 20 into 3 the 60. So omega is equal to 4 upon 3 pi. Clear? Okay. So we know that force centripetal should be equal to m v squared upon r, or m omega squared r. One second. Uh, am I right? Let's see. They have done by a different method. Okay. M omega squared r. Let's see. So you have m is equal to how much? 0.25 omega 4 upon 3 pi the whole square multiplied by 1.5. Okay. So I'll get 0.25 can be written as 1 by 4 multiplied by 4 multiplied by 4 upon 3 multiplied by 3 multiplied by pi square multiplied by 3 by 2. So I've written 0.25 as 1 by 1 upon 4 and 1.5 as 3 by 3 upon 2. So this 3 and this 3 gets cancelled. This 2 and this 2 becomes equal to 2. This 4 and 4 gets cancelled. So you will be left with 2 by 3 pi squared. So what is 2 by 3 pi squared equals to? 2 divided by 3 is equal to multiplied by 6.57. This is correct. Yeah, 6.57. 6.57 newtons. In the book, they have given it as 6 is equal to 6.6 newtons by rounding it up. Clear? So, revolutions per minute, how do we convert it? You understood, right? So, if first convert 40 revolutions per minute into omega, you will get the value of omega as rad per second. Okay? Then, Fc is equal to mv square upon r is equal to m omega square r is equal to this value. I converted this into my 6.6 newtons. Any doubts here? Drupad, any doubts here? Okay. So, they are asking us, if T max is equal to 200 newtons, what is V max? Okay, they radians per second only they want us, no? Um, okay, so you have, we know that tension is equal to mv squared upon r. So T max is equal to m v max the whole squared upon r. Therefore, V max is equal to T max multiplied by r upon m, the whole root. Okay, so what do I get? Uh, Root under V max is equal to root under 200 multiplied by 1.5 upon 0.25. Okay, so I'm just going to simplify this. Is equal to root under 200 multiplied by 3 upon 2 into 1 multiplied by 4. Okay, so this will become 100, 400, 1200. So basically it is equal to root under 1200. So for 20 root 3 is equal to 20 root 3, right? 20 root 3 meters per second. You should learn how to organize and write. This is always horrible. The answer is 20 root 3 meters per second. What is 20 root 3 coming out to be? 20 multiplied by root 3 is equal to 34.64. That is correct. Is equal to 34.64 meters per second. So this is the maximum speed that you can go. 1 second. 1 second. So I hope you understand this question. We are going to go continue with more questions in the upcoming videos. Okay. Not. I'm not going to post more numericals immediately. Okay. I'm going to go into next chapter. We are going to finish periodic classification of elements, and then we will when we get free time, I'll post more videos where I solve numericals. You can solve numericals with me. So I hope you really like this video. If you like my videos, please do like, share and subscribe, and I'll see you in the next video. Bye.